This is Note-Taking Guide 3.4 for Math 1. Today we're going to talk about some important parts of graphs. We're going to talk about intercepts, maximums, minimums, and symmetries. So the very first thing that I want to talk about is intercepts. So we have what we call x and y intercepts, and x-intercept is where the graph touches or crosses the x-axis. So here's my x-axis over here, and x-intercept would be where my graph touches or crosses the x-axis. So it touches right here on the x-axis. So that happens where y equals 0. So let me tell you what I mean by that. So if I were to write this ordered pair as my x-intercept, I would be over 5 and up 0. So if you notice, the y value equals 0. So when we want to find our x-intercept, we actually set y equal to 0. The same thing happens when we want to find our y-intercept. So y-axis this time, where does my graph touch or cross the y-axis? It does right here. This ordered pair would be 0, -3. So if you notice, my x value is 0 this time when I want to find my y-intercept. So to find my y-intercept, I set x equal to 0. To find my x-intercept, I set y equal to 0. So that's just going to help us a little bit when we're solving for our intercepts. So it says find the x and y intercepts of this graph. So again, x-intercepts are on the x-axis. So this doesn't actually going to have one. This is a graph that's going to come along the x-axis right here. It's going to approach it but never touch it. So as far as x-intercepts, we're just going to put there is none. Or you could put undefined like that. That would be okay. There isn't one. Okay, y-intercept on the other hand, though, is where my graph touches or crosses the y-axis at. That ordered pair is 0, 1. So I can use the ordered pair 0, 1, or you can put y equals 1 as your y-intercept. And it's okay for there not to be one of the intercepts. I know that this might make some people a little frustrated. They're like, I don't know how to find the intercept. Well, it's okay for there not to be one. If it doesn't touch or cross that y-axis or x-axis, it doesn't have an intercept there. Okay, the next thing we're going to talk about is a maximum or a minimum of the graph. The maximum is what I like to call the top of a mountain. So if I have a graph that looks like this, a top of a mountain would be up here. Okay. A minimum is the bottom of a valley, so down over here. So what we're going to do is we're going to list these answers as ordered pairs because we want to know their value of where they're at. So this graph right here only has a minimum because it only has a bottom of the valley. That minimum point is over 1 up 0. So over 1 up 0 is my minimum value. Okay, find the minimum and maximums of the graph. So it's okay for there to be more than one minimum, more than one maximum. You can have a minimum and a maximum. So if we're actually looking at this, we can see that there's two tops of the mountain. So we know we have two maximums, which is awesome. It's totally fine. So let's just list those as ordered pairs. So I went over -2 and up 16 for my first one. Over 2 and up 16 for my second one. Okay, my minimum is the bottom of a valley. So here's my bottom of my valley right here. There's my minimum point. That ordered pair is actually at 0, 0. So on this graph, I had one minimum and two maximums, which is okay. So that's how we find a minimum and maximum. All right, the last thing we're looking at today is to find the line of symmetry if there is one. So a line of symmetry is a line where you could fold the image in half and it makes it exactly on top of itself. So for instance, if I cut this shape directly in half right there and I folded my piece of paper, this shape on this side is exactly the same as this shape on this side, and they would fold right on top of each other if I use that line of symmetry. So the question is, where is this line of symmetry and what do we call it? Well, if you notice right there, that line of symmetry goes down right through the number 2. So the question is that an x equals 2 or a y equals 2 line? Well, all vertical lines are x equals lines, so this is going to be x equals positive 2. If it was a horizontal line, it would have been a y equals line. All right, so our line of symmetry is at x equals 2. What about our line of symmetry this time? Right here is where we would cut it into 2 equal pieces. So this is a horizontal line. A horizontal line we know is a y equals line. So where on the y-axis is my value or my line at? It's at y equals 0. So in order to draw my line of symmetry through this, it's going to go right here where y equals 0. All right, this next one says find the x and y intercepts, the maximums and minimums, and the line of symmetry. So let's start with the x-intercept. The x-intercept is where my graph touches or crosses the x-axis. It does it here at 5, so I have an ordered pair of 5, 0. And it does it here at negative 3, so I have another ordered pair of negative 3, 0. My y-intercepts are where my graph touches or crosses the y-axis, which is right here. So that is over 0 and up 90. That's a bad 90. And that is how I find my x and y intercepts. So let's go to maximums and minimums now. Maximums are the tops of mountains. So I have one top of a mountain right here in this area. I kind of have to just pick where that's going to be at. I think the top of the mountain might be like right here. So I'm over 2.5. And I'm up at 150 for my ordered pair. My minimum is at the bottom of a valley, and we've already used that point for an x-intercept, but it's okay to use it as a minimum also. So that's going to be negative 3, 0 for my minimum. And then my line of symmetry, is there any place I can draw a line that cuts this into 2 equal pieces that would fold exactly on top of itself to be the same shape? And the answer to that is no, there is not some place that will do that. So there is no line of symmetry. Okay. All right, one last example on this. It says find the x and y intercepts, the maximums and minimums, and the line of symmetry. And then we added on domain and range from last week. So let's see if we can figure out all of those. So x and y intercepts, let's start with it. The x-intercept is where your graph touches or crosses the x-axis. So there's 1 point right there. So I'm over 1, 2, 3, so negative 3, 0. My y-intercept is where my graph touches or crosses the y-axis, and there's only one of those, which is right here. So we're over 0 and we're up 2. All right, our maximum is where we have a top of a mountain. So we've already actually used the maximum as a point of intercept, and that's okay. So that maximum is up 0, 2. And that's the only maximum that I know of, because this is a continuation, so we don't know where it's going to stop, and we don't know where this is going to stop. So do I have a minimum, which is a bottom of a valley? I do have one. I'm going to say it's about right there. So I'm over 1, 2, 3, 4, so 4.5 and up 1/2 maybe. So 4.5, 1.5 maybe for my ordered pair. Line of symmetry. There's no place I can cut this into 2 equal pieces and have it fold on top of itself, so I'm going to put none. I'm going to do my domain now and my range. If you remember, my domain is left to right. How far left does this graph go? So that arrow right there tells me it's going to go forever to the left, so to negative infinity. How far right is this graph going to go? Well, that arrow tells me it's going forever right, so to positive infinity. And then range is bottom to top, so how low is this graph going to go? Well, it's going to continue down to negative infinity. And how high is that graph going to go? It's going to continue up to positive infinity. So those are some important features of our graphs. Good luck with your homework.